all in one curve here, or one slide, the left upper there would be VCO2 versus VO2, using the modified V-slope method to drop the anaerobic threshold line down to find the VO2, at which point the rate of CO2 production started to exceed the rate of O2 consumption. Right next to that is VE versus VO2, so minute ventilation. Minute ventilation will go up parallel with oxygen consumption until you hit anaerobic threshold. Above anaerobic threshold, minute ventilation is going to go up at a disproportionate rate because we primarily breathe in response to CO2 production. And then the lower left one has the ventilatory equivalents for both O2 and CO2. So the lower left curve there, so we're looking at the lower left, and the lower curve of those two is the ventilatory equivalent for O2. So at anaerobic threshold, we'll start breathing more than the amount of oxygen we're consuming, so the ventilatory equivalent for O2 will go up. Notice, for a little while, the ventilatory equivalent for CO2, which is a second curve, stayed flat because minute ventilation is tracking with CO2 production. And then at this point, even the VECO2, the ventilatory equivalent for CO2, goes up, which is called the respiratory compensation point. At some point, we lose buffering ability. We produce so much lactate that we can't buffer anymore, and the pH starts to drop. So now we start breathing, not only to get rid of the CO2, but to compensate for it. So this latter point, which is a little bit further from anaerobic threshold, is the respiratory compensation point. At that point, minute ventilation goes up even disproportionate to CO2 production. I'm not 100% sure there's any clinical utility to identifying this respiratory compensation point, but it's talked about in all exercise discussions such as this. And then our end tidal O2 would go up at anaerobic threshold because we're breathing more than we're consuming oxygen, leaving more oxygen left behind in the expired gases. And meanwhile, at respiratory compensation point, the end tidal CO2 would go down because at that point we're breathing more even than CO2 production. So that may be the end of it's not the end of the theory. Anaerobic threshold, as I mentioned, is usually somewhere in the middle. If you're calculating this, it's very important to remember on an exercise test, everybody reaches a maximum VO2. Because at some point they stop.